All right, welcome back grade 8 to another math video. In this video, this is kind of a continuation of our scale factor video, but we're going to talk about enlargement. Now generally we use the term enlargement to talk about when an object gets larger and reduction to talk about when an object gets smaller. But sometimes we use the word enlargement to refer to both. We talked about before how an object getting larger is when we have a scale factor that is bigger than 1. And it could be just a little bigger. It could be 1.1. But it's larger than 1. That means it's getting bigger. It's an enlargement. If the scale factor is less than 1, and it could be judged by just a bit, maybe it's 0.95, then it is going to be a reduction. It's going to get a little bit smaller. Enlargement is a transformation that produces an image that has the same shape as the original, but has a different size. So we are going to be creating similar shapes once again. An enlargement is determined also by the center of enlargement, which is something we haven't referred to very much yet, and that we're going to refer to here. In this example, I have two different shapes that we're going to be taking a look at. This one here, we have a shape within a shape. So we have, here we have, SPQR, and we have larger image SPQR surrounding it. In order to find out the center of enlargement, and we're going to be practicing this, we need to create straight lines connecting the point with its image point. So in this case, point P. In this case, point Q. In this case, point S. In this case, point R. And where all of those lines meet, that is the center from which the enlargement is taking place. And as we're going to learn in a little bit, we get a scale factor that helps us to determine how large that object is and how far away it is. And if we start at this center here and figure out this distance to the point of the original shape, and then multiply that by the scale factor, we figure out where the point of the image is going to be. So in this case, if this is, let's say, 2 centimeters, this is a scale factor of 2. Then if I multiply the scale factor by the original length of the object, I'm going to get the image length. All right, we talked about how scale factor equals image length divided by object length. So if the object length here is 2 centimeters, I multiply that out, so image length also equals scale factor times the object length. Running out of room here, but hopefully that makes sense as we work it around. So 2 times 2 centimeters, which means from this point to this point, this new point here, is going to be 4 centimeters. It's important to note that it's from the point of origin and not from where this point ends. But it's going to be twice as long, 2 times as long, as this original length. And I can do that for all the rest to figure out where my remaining points are going to be. Now this was a random point that's at the center. In this example here, you see I have W, X, Y, Z. I have the shape here. And then I also have W, X, Y, Z, this larger shape that kind of comes off of it. In this example, we had point O as the center of enlargement. In this example here, we have vertex X right here. This is the center. If I were to draw a line in all these different lines here, that's where they cross as the center of enlargement. Excellent. So not only does scale factor equal image length divided by object length, but we could also figure out scale factor by doing the distance of the image from the center of enlargement divided by the distance of the object from the center of enlargement. So that one, if I knew this was 4 and I knew this was 2, I could also do 4 centimeters divided 2 centimeters to figure out that my scale factor here is also 2. So just another piece of information in order for us to figure out scale factor as we work through these particular types of questions. Just to give another quick example here, this one I'm not given any information about what point they are going to be enlarged from. I have my original object, which is right here. I have my other object, which is right here. You'll notice that although I'm talking about enlargement, it's actually becoming smaller. If I connect these two lines and just continue that forever and ever, who knows where that's going to go? And then I connect my B lines here. Just continue that in either direction. And then I connect my C lines and continue that in either direction. You'll notice there's this special point right here that they cross, and that is the point. This is what we're going to say is the point of origin, or the point at which they are going to be enlarged from. And so this is the special point that we're looking for. We could call it whatever we want, but this is the center of enlargement through which things are enlarged, or in this case reduced. This might be a scale factor of 1/2. And so if the distance from the center of enlargement to the image, let's say that's 6 centimeters, and the distance from the center of enlargement to the actual object, 12 centimeters, that would give us our scale factor of 1/2. And if I only knew 2 of those bits, I could use that information to solve for the remainder. We're going to do some work both with figuring out where things are being enlarged from, the point of enlargement, as well as figuring out scale factor with this. And we may even throw in some transformation questions with this as well. If you feel like you have a bit of a grasp on this already, you can stop the video here and you can go work on those questions. If you'd like, we're going to be stepping through example 12 and example 13. I have pictures of those attached to this assignment as well. But if you'd like, you can stick around and I'm going to be walking through those 2 examples as well. Okay, let's take a look at example 12. I have a bit of a drawing for example 12 here already. And it says, in the diagram, triangle ABC, the image triangle ABC, that's with the little ticks next to it, is an enlargement of the original triangle ABC. We can see that, right? This is the original, this is an enlarged version of it. The first part says, find the coordinates of the center of enlargement, which they're just calling point P. Well, in order to do that, I kind of connect my lines here. I continue to draw. I can do the same with B. B is nice because it's on a nice straight line here. I can do the same with A. And hey, look, where do they cross? They cross right at this point here, which we're going to call point P. And if we were to take a look at the coordinates at which they cross, those are at 0, 1. So that we say is the point of enlargement, or the center of enlargement. What is the value of the scale factor? That's part B of this question. Well, there's a number of ways that we can solve that. The easiest is using a straight line here. We have a straight line both here and here in A and C. So if you remember, to figure out scale factor, we take the length of the image on top, so A naught, C naught, over the length of the original on bottom, AC. If I could just count these up, right? So the object here, it goes up 1, 2, 3, 4, 5, 6 spaces. And the original goes up only 2 spaces, which when we figure all of this through, we get a final scale factor of 3. So that's our final scale factor here. The last part of this just asks you to describe the enlargement. Whenever a question asks you to describe the enlargement, there's 2 bits of information that they are looking for. They are just looking for what is the point that it is enlarging from, and what is the scale factor. So the answer for that one would be that triangle ABC is mapped onto triangle A naught, B naught, C naught by an enlargement about center P, which is 0, 1, and with a scale factor of 3. That's just putting all the pieces of information together that we've already solved, that we've already worked through. That's example 12, and when you go through your question on the try it 12 is very, very similar to that as well. Let's take a look now at example 13, a question that is much more complex. Example 13 says that the vertices of triangle A, B, and C are at A is negative 2 and 0, B is at 0 and 4, and C is at 4 and 0. The transformation E, okay, so we're going to be doing some transformations. We're calling our first transformation E, is an enlargement about the point 6, 4. Okay, so we're given the enlargement point at 6, 4. So this is our enlargement point here. And a scale factor of 1/2. Okay, now we have that information for transformation E. So in other words, we're going to have to figure out how far all of these distances are away from this expansion point and multiply them by that scale factor of 1/2. In other words, this is a reduction. So this triangle, the one that we have right here, is going to end up getting much smaller. So this one is a nice easy one to do to begin. It starts here. It is 6 away. And so 6, 1/2 of 6, or half of 6 is going to be at 3. And so that's this point here. This is where we have B naught, or the image of B. C, this one is a bit tricky. We go over 2 and up 4. So half of that is going over 1 and up 2. You can also measure that line and you can see where is exactly the half point there. A goes over 8, 2 here and 6 here, and up 4. Half of that is going over 4 and up 2. And you can see kind of where those half points are. If I were to now connect the dots, I now have A naught, B naught, C naught, which is under transformation E of scale factor 1/2 off of the point 6, 4. Now, unfortunately, it doesn't end there because it does ask you then to go through transformation R. So now we have transformation R, which is a rotation, back to that now, of 180 degrees about the points 3, -1. Okay, so now that we have that, 3, -1 is right here. That's the point that we are going to be now finding the rotated image of. If you don't remember, so we've now done this, to figure out a 180 degree rotation, we just get a single point. We figure out how to get to the rotation point, and then we just continue past it the exact same amount. So if we continue past that the exact same amount, we end up right here, which is our new image for C. We're going to have 2 lines next to it because we already have our original C. We have our first image of C, and this is now our second image of C. We do the same thing with A. Continue that straight past and figure out where that's going to end up. And then we do the same thing with B. B is a nice straight line down. Okay, we're going down 5, so we continue down another 5 until we get right to here. That's our second image of B. We connect the lines here. And now this is our new triangle under rotation R. So in the textbook it does ask you, or in the example 13, under B it says plot and label triangle A naught, B naught, C naught that underwent transformation E. When this underwent transformation E, we went through this whole process of figuring out where the point was, figuring out where the scale factor was. We got this triangle here. Then we went through transformation R, which is a rotation of this. And so we took this image, we rotated it around this point, 180 degrees. You'll notice that our A is in a different spot, or C is in a different spot. It's completely rotated or spun around that particular point, and we get this new object here, which we could map out. We could say that this is at 4 comma negative 4. This one is at 1 and negative 4. And then this point here is at 3 comma negative 6. And that is how we combine a lot of the pieces of information that we've done already. We've now learned how to do scale factor. We've now learned how to do enlargements and reductions. And we've just pieced that together a little bit with our information on transformations in order to really manipulate some of these shapes and objects in order to create similar shapes and objects from our original. When you're working through your questions, please keep in mind that try at 12 is going to be very similar to the first example that we did, and try at 13 is going to be very similar to this example that we did. So as you work through those bits of information to figure out more about working with similar triangles with enlargements, reductions, scale factor, and transformations, that you can always take a look back at those, and I've added those PDFs to your assignment.